All right, so let's start with our bell work for today. So I want to just go over with you guys, like, how do you simplify roots? Now, we've done square roots before and we've done cube roots before. But let's just kind of review how do you do that and how do you use your calculator to help you simplify this. Now, first off, square root of 25, this is a very familiar problem. It's something that you do pretty often in your previous math class. So when you're taking a square root, you have to ask yourself what two numbers that are the same that multiply to give you 25. Well, in this case, 5 times 5 gives you 25. So the square root is going to be 5. The square root of 25 is 5. That's because in this case, when you are doing a square root, there's actually, notice how there's no number out here, but for cube root, there's a 3, right? So by default, a square root actually has a 2 out here. You just don't see it. That 2 represents, is asking you what two numbers that are the same when multiplied gives you the number inside the root. So in this case, 5 multiplied itself twice gives you 25. So the answer here is 5. Whereas this one, it's asking you what number multiplied itself 3 times gives you negative 64. So you can use the calculator to figure this out, or, just guess and check. So if you do 4 times 4 times 4, 4 times 4 is 16. 16 times 4 gives you 64. But because this is a negative, right, that means I have to have negatives for every number. So negative 4 times negative 4 gives me positive 16. 16 times negative 4 gives me negative 64. So the cube root of negative 64 is negative 4. Now, I did that by guessing and checking, but I'm going to show you how you can do this on your calculator. So on the calculator, if you press the button Math and option 5, so this is on a TI-84 calculator, so option 5, you will get this like root where you can stick in any root up here, and then whatever number is inside your root. So let me demonstrate this. I'm going to switch my camera here. Let's see if I can get this to video. There's my face. So I'm going to switch the camera. Alright, so here is my graphing calculator. So you can see here, I'm going to be hitting Math right here. So I'm going to press this button. And then this feature pops up, and I'm going to press option 5. So you can literally use your control pad or just press the number 5. So I'm just use my control pad and hit enter. And there we go. Notice how that pops up. Okay, so mine's a newer calculator, and it will make a box right here, and I just put in my digit. Now for you guys, actually, you know what? I'll do this on an old calculator. What am I doing? Let me grab an old calculator here. I'll change my mind. So here's an older calculator. So I'll turn it on. Again, I'm going to hit Math, and I'm going to hit option 5. So let me just press 5 this time. And there it is. So an older calculator, this ANS or answer comes about, and what you have to do is use your control pad, so right here, and just go on top of it, and you're going to replace it with the number that you want. So keep in mind, a moment ago, I had a 3 up here. So this was a cube root of negative 64. Oops, that's too many 6. There we go. So cube root of negative 64. So I put the number in, and I'm going to press enter. And I get negative 4, which was the answer that I got from guessing. So you can definitely use your calculator. Like, I'll do the next problem here. But Math, if I go back to option 5, hit enter. And this one will be the 6th power, and I think there was a 1 inside. Hit enter, so that is a 1 here. And then the next one I think was a 5th root. So I'm going to go back to Math, and I'm going to go to option 5, and I think it was the 5th. Oops, sorry, this should be 5. And then inside, I think I wanted to take the fifth root of 243. All right, so I'm going to just keep all those answers right there. There we go. I'm going to pause the video right there. If this will pause for me. Oh, there we go. That's why. Okay, so let me just set that video aside here and kind of show you what I did. So I used the calculator to figure out all these answers here, but I could have done it by hand, right? Like if I take the 6th root of 1, I'm just asking myself what number multiplied 6 times gives you 1 on the inside, right? So we know that if we multiply 1 6 times, I'm still going to get a 1, right? So the answer to this problem is definitely a 1. I didn't have to use a fancy calculator to do that. So the square root of 1 is always 1. This one's the 5th root of 243, and this is where maybe a calculator would come in handy. You could do a factor tree, or you could start guessing and checking. But in this case, turns out, if you look at my calculator here, the 5th root of 243 is 3. So this answer is 3, and you can double check if you take 3 and multiply it by itself 5 times, you'll get 243. So like I said, the calculator is super powerful, but one of the things I want to mention is, like I said, if you want to get to the root button and press in any type of root, it's math option 5. But I want us to look at these 2 different problems. Notice how this one's a negative number underneath. Now, I'm always get a kid that asks me this question. It's like, Miss Chang, I remember from first semester that when you have a negative a negative number and you take the root of it, you should get imaginary numbers. And he's not wrong. The only thing, it only happens for this type of situation. And I'm going to show you when does it happen. So it only happens when you have a square root or an even root. So take a look at this. If I had the square root, let me put it up here just as a random problem to show you. If I had the square root of negative 25, okay, 2 numbers that multiply to give you negative 25. I'll just tell you right now, it doesn't exist, right? Because in this case, if I were to break this up as, let me erase this and put this somewhere else. If I were to do it right here, square root of negative 25, I know that negative 5 times negative 5 gives me positive 25, not a negative 25. So what I'm saying is that a square root can never be a negative inside. This would give you an imaginary number, so this would be 5i. Okay? So whenever you have a square root, okay, or an even root, so like this 6 here is an even root. So anytime, let me make a little note here. So anytime you have an even root and you have a negative number inside the root, you're going to get an imaginary number. But anytime you have an odd root and you have a negative number, like the one that we have here, so notice how this is a cube root, it's an odd number, and it's a negative inside. Well, you can take the cube root of it because there's a odd number of negative signs, which is what causes it to be a negative inside. When you multiply a negative 3 times, you're always going to get a negative out here. Or when you multiply by an odd number of negative numbers, you're always going to get a negative number. So it turns out when you have an odd root with a negative number inside, it's just going to give you a negative number. Okay? So I want to kind of just keep this note here because it is something that we will come across. So this is kind of an important side note before we start in today's lesson. So these 2 notes, knowing how to use the calculator and knowing about even and odd roots when you have a negative underneath, are going to be relevant in the problem solving that we'll see later. Okay, so let's get into today's lesson, and it's all about roots today and how you handle them. All right, so in this first slide here, I have this formula, but this formula is actually incomplete. Notice how I just have an a here, and apparently it equals the square root of the n and m, whatever they mean. So how in the world is this just a, right? Well, it's because it's missing something, and we're going to figure out how to complete this formula. But before I do, let's go over a and b. So before I think about, this square root here, I want us to just look at a to the 6th power. So a to the 6th power. Isn't that just, let me grab my green pen here. A to the 6th power is just a times itself 6 times, right? Because we learned a fairly long time ago that when you multiply the same variable, you take the exponent, so all of these are 1s, right? You would take the exponents and you would add the exponent. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 gives you a to the 6th power. But here's the thing about roots. Roots actually help you group things and figure out how many should be in each group to make it an even sharing. So what I mean is a square root, remember when we were talking about square roots, the default number that's outside of a square root is a 2. So technically it's a 2 out here. What that is saying is that you need to group your 6 A's into 2 groups, and there should be an even amount of A's in each group. So first off, there are 6 A's. I have to have 2 groups. In this case, if I have 2 groups, I'm going to put 3 A's in each group, because in that case, I have an even amount or the same amount of A's in each group. And I can only have 2 groups because this is a square root. And if I look inside each group, that's 3 A's right there. So if I multiply them, this is a to the 3rd power times a to another 3rd power. So basically, square roots or any roots are, in a way, dividing up the number of factors you have. So in this case, based off my group here, the square root of a to the 6th is a to the 3rd. So my answer here is a to the 3rd. Because that's how much I have in each group, and they have to be an even amount. So let's try it with this one here. So this is a to the 12th, so I'm going to be a little bit obnoxious, but I'm going to write out all the A's here. So this is A's 12 time. So that's 4 A's, that's 8 A's, that is 12 A's. So this time, this is a cube root, so that means you need to have 3 groups, and it should be an even amount of A's inside. Well, if I think about this, there are 12 A's, right? So that means I probably want to keep, let me do that in pink. I probably want to keep 4 A's in each group. So let's see here. Yep, that seemed to work, because in this case, each group has 4 A's, which is exactly what I want. I want to make sure every group has the same amount of A's. And so in this case, this is a to the 4th power in each group. So this tells me the cube root of a to the 12 is a to the 4th power. And then I'm finished. So let's brainstorm here for a formula. So it looks like in this problem here, I basically took the 6 and I divided it by 2 to get that new exponent. And I did the same thing here. I took the 12, I divided it by 3, and I got a 4, right, as my new exponent. So what you're doing is you're taking the exponent, I'll call m here since it's inside the exponent, and you're taking n, which is outside of the root, is called the root. So the number outside is called the root, the number inside is called the exponent. So when you take the root of an exponent, you actually divide the exponent with the root. So in other words, a is m over n. So anytime I want to figure out what is the root of an exponent, I just take the exponent, divide it by the root. And then here's my new exponent. So this is how you would deal with variables with an exponent and you're taking a root. So let's try that formula with this one here. So I have an x and a y. So I'm going to get an x and a y here. So let's start with the x. So this x here is to the 16th power. And so that's my exponent, and I have to divide it by the root. So 16 divided by 8 gives me a 2. And then this y is to the power of 8. So I'm going to divide that by also the root. So 8 divided by 8 is 1. Or you don't even have to write the 1 because it's kind of redundant. And so then this is my final answer. Once I have gotten rid of the root, I know I'm done. Okay, so let's try some more example problems together before we get into the homework packet. So I want to start us off with this problem here. Notice how I have variables, okay? But I also have a number or a constant out in front of the variable. And so you have to deal with that. And then I have some negatives here, and I've put some parentheses to make it more variety. So let's start here. So start with your number. So your number, the biggest mistake that I have students do is they apply that division with the number. So they take 32 and divide it by 5 and then they get their number, but that's not how we take a fifth root, right? So we actually have to take the fifth root of 32. So let me just do that to the side here. Now some kids will just plug this into their calculator and figure out what that number is, and that's fine, but I want to show you how you can do this by hand too, because not every problem you can just stick in the calculator. So if you were to do this by hand, you have to build a factor tree. So to build a factor tree, you start off with two numbers that multiply to give you 32. So I'm going to start out with 8 times 4. Okay, 8 times 4 gives you 32, but they are not prime numbers. In other words, 4 can break down into 2 and 2, and 8 can break down as 4 and 2, and 4 can be broken down as 2 and 2. So you're going to ignore your non-prime numbers. So in other words, 8 and 4 are not prime numbers. Your prime numbers here are the 2's, and you have about, that's 1, 2, 3, 4, 5. You have 5 2's here, which is perfect because you're taking a fifth root. So notice how I have 5 groups here, and in the group is just a 2. So the fifth root of 32 is just a 2 because 2 multiplied itself 5 times does give you 32. So in this problem here, I've basically figured out what is the fifth root of 32. And I'll write the 2 out here. The next thing I want to do is now take care of the variables. So this a is to the 15th power. So I'm going to take the exponent and divide it by the root. So 15 divided by 5 gives me a to the 3rd power. And b here is to the 10th power. So 10 divided by 5 gives me a 2. And then this is my final answer because I've gotten rid of the root. All right, so this problem here, first off, let's make sure we write the root out here. This is a square root, but a square root has a 2 here by default. We learned that. Now, I'm going to say that parentheses, anytime you have a parentheses, those are my favorite. And the reason why is because you can treat the parentheses as a unit, so you don't have to mess with anything inside the parentheses. All you have to do is just bring it over. So I'm going to bring over the 2x plus 1. So I'm basically copying and pasting it over, and I'm only going to deal with the exponent that's outside of it. So just like before, I have to take this exponent, so 6, and divide it by 2, which is the root. So 6 divided by 2 gives me a 3. So then that's it. I'm done. So when you have a parentheses, you just drag that over or copy, paste it over, and then just take care of the exponent that's outside. You don't need to actually raise this to the 3rd power. That's a lot of work, and also it would just make it much messier, and I want you guys to have just the simplest form. Okay, so this next one here is negative 4, 81, and x plus 4 to the 4th power. So first off, this is the 4th root, and so in this case, I have to take the 4th root of 81. So let's do that first. So I'm going to do a factor tree again. 2 numbers that multiply to give you 81 is 9 and 9, which are not prime numbers because they can be broken down as 3's, right? A pair of 3's. Now, like I said, we're going to ignore our numbers that are not prime. So the numbers that are prime is the 3's that are below. And there are 1, 2, 3, 4 3's, which is perfect because I'm taking a 4th root. So the 4th root of 81 is actually a 3. Now, I do want to mention for a moment, see this negative sign here? If you have a negative outside your root, all you have to do is bring that over. So I'm going to bring over the negative, and now I'm going to bring out a 3, because we just said a moment ago the fourth root of 81 is a 3, so I brought that over. And then I have a parenthesis, so I'm going to copy, paste that over. So this is x plus 4, but this has a 4 out here, so I have to take care of that. So 4 divided by 4 gives you 1, or you don't have to write the 1 anyways, since that's redundant. And then that's it. This is your final answer, because you've gotten rid of the root. All right, last one here. This is a cube root, and there's a negative inside. So I want you to think back to that bell work. If you have a odd root or a cube root, right? If you have a negative number inside, ask yourself this: is this going to be an imaginary number, or is it okay to take the root of this? So anytime you have an odd root, this is okay. It's only when you have an even root and you have a negative inside that you couldn't actually take the root of. So this is fine. So if I were to make a factor tree of negative 27, two numbers that multiply to just give you 27 is 9 and 3. 9 can be broken down as 3 and 3. And like I said, we ignore numbers that are not prime. So in this case, it looks like the only prime numbers I have are these 3s. And I have 1, 2, 3 of those 3s. So in this case, to get a negative 27, they're not positive 3. They're actually negative 3s, right? Because negative 3 times negative 3 gives you positive 9. Positive 9 times negative 3 gives you a negative 27. So in this case here, this is a negative 3 is the cube root of negative 27. X is to the 18th power, so 18 divided by 3 is x to the 6th power. And then y is to the 6th power divided by 3 gives you a 2. So this here is my final answer. And that's it. So in the next slide here, I'm going to do 4 problems from the homework and then try to do the rest on your own. Alright, so I picked out 4 problems for us to try. So I picked out 1, 2, 4, and 7. So let's start off with number 1 here. So number 1 will have like this square root, right? Because this here is just a square root. So technically, the number that's outside of here is a 2. So we have to take the square root of 121. So if you're really good at your multiplication table, then you might know that 11 times 11 gives you 121. If you don't, just use the calculator, take the square root of 121, you'll get 11. So I've done the first part. The square root of 121 is 11. Now I'm going to take care of this x. This x is to the 4th power. So again, remember, we always take the power, the exponent, and divide it by the root. So 4 divided by 2 is x squared, or x to the 2nd power. Y is to the 16th power, so 16 divided by 2 gives me 8. And then that's it. That's my final answer. This next one here, number 2, has this negative sign outside. So anytime you have like a negative sign, we just, bring it over. So I'm just going to make a equal sign and then bring the minus sign over. I have to take, it looks like this is a square root. Since there's not a number out here by default, it's going to be a 2. The square root of 400. So if you do that in the calculator or you just do this by hand, turns out 20 times 20 will give you 400. So the square root of 400 is 20. And then this x is raised to the 32 power, so 32 divided by 2 is 16. And then y is raised to the 40 power, so 40 divided by 2 is 20. And so then from here, this is my final answer because I have taken the root of everything that's inside. Okay, so now you have this problem here. Again, you have a negative sign outside, so I'm going to bring it to the side here. Just carry that over. Now, this one is pretty nice because it's just a parentheses and an exponent. So whenever it's just a parentheses inside, we just copy and paste that out. So this is going to be 2x plus 1. And then this exponent is to the 6th power. And the exponent out here is a square, right? So this is a 2. So I have to take 6 divided by 2, and that's going to give me a 3. And so this is my final answer. I have negative 2x plus 1 to the third power. Okay, last but not least. So this is the one that can cause people some issue because I have to take the fourth root of 256. I'm going to show you how you could do this using a factor tree, and you can always obviously do guess and check and figure out what number is the fourth root of 256. You can use your calculator or guess and check. But I'm going to show you how you can do this by hand. So 256, let's just think about it for a moment. This number is an even number, so I'm going to always start off by just dividing the number by 2 if it's even. So 256 divided by 2 is 128. So 128 times 2 gives you 256. 128 is also an even number, so if I divide it by 2, I actually get 64. Now 64 is a number that I'm familiar with. Two numbers that multiply to give you 64 is 8 and 8, and 8 breaks down to 4 and 2. 4 and 2. Let me move this a little bit. There we go. Okay, and then 4s break down to 2 and 2, 2 and 2. So again, I'm going to ignore the numbers that are not prime. So 128, 64, 8, and 4s all break down. So I can't use them. And when I look at everything, it looks like I just have a bunch of 2s, right? So that's 1, 2, 3, 4, 5, 6, 7, 8. 8 2s. So think about it. You have 8 2s, and you're trying to put it into a group of 4 evenly. That means if you have 8 2s, you should be putting 2 in each group. Let's just double check here. Yeah. So notice I have 4 groups. And in each group, I have 2 2s. So if you do 2 times 2, that's actually 4, right? So it turns out the fourth root of 256 is actually 4. So I'm going to write this out here. So this is a 4. Now that I'm done taking the fourth root of this number, I can actually deal with the parentheses. So this is a parenthesis, so I'm going to copy, paste that over. So 5x minus 2. And then this exponent here is a 12, so 12 divided by 4 is a 3, and now I am done. Okay, so that's it on the homework here. So try the others on your own. I hope this helped you out. See you again next time.